Hello and welcome to a continuation on how to do trigonometric integrals. In this presentation, we're going to tackle integrals of powers for the tangent and the secant functions. Now, for the cosecant and cotangent functions, they're pretty much going to be handled the same way as these. So let's go ahead and just do an example, get us started here. So we're going to go ahead and draw. And we're going to do line width. And let's say that we have the example, the integral of tangent to the fourth power of x dx. Okay, so we're going to evaluate this integral here. Now, we know that we can rewrite tangent to the fourth power as a product of tangent squared times tangent squared. We also know that the tangent squared can be rewritten from the Pythagorean identities as one, or I should say, let me put this in the better order here. We're going to say secant squared x minus 1 dx. I'm going to distribute. So here I have tangent squared x secant squared x dx minus tangent squared x dx. I'll put the integral in here. And now we can, again, split up the tangent squared by the Pythagorean identity. So we have tangent squared x secant squared x dx minus 1 minus secant squared, oops, and then backwards, secant squared x minus 1 dx. And then what we can do is I'm going to call this guy first integral, this guy second integral. And the first integral is we're going to take the integral of tangent squared x secant squared x dx. And we're going to do a u substitution. We're going to make u equal to the tangent of x. Du, in that case, is secant squared x dx. So this is just going to be the integral of u squared du. And we know that this is 1/3 u cubed plus a constant. And again, if we substitute in the u, start in x, end in x, we have tangent cubed x plus c. So there is the evaluation for the first guy. For the second guy, we have secant squared x minus 1 dx, which is equal to secant squared x dx minus the integral of 1 dx. And in this case, we're going to let the integral of secant squared, okay, remember that this is one of the trigonometric integrals, so that simply becomes tangent x plus some constant plus the integral of dx, which is just x plus another constant, which we can rewrite simply as tangent of x minus x, sorry, not plus x, but minus x. Minus x plus some other arbitrary constant. So our final result, and I'll put that up here in black, final is going to be 1/3 tangent cubed x plus some arbitrary constant. And then we have minus this result here, tangent x minus x plus some another arbitrary constant, which we'll just call that C2, C1 and C2. And our simplifying result becomes minus tan x plus some arbitrary constant in its entirety. And we have our final result down here in the lower corner. So again, when you're confronted with tangents to powers, it's very, very common to split them up and use that Pythagorean identity. When you have secants, hopefully you'll be able to associate secant squared as the derivative of the tangent. Or if you have secant to higher powers, hopefully you can somehow combine them with a tangent, and that way you can go ahead and use U substitution. Okay, so there are plenty of techniques to handle tangents to higher powers. So let's look at another example here just really quick. In this example, we're going to consider the integral of secant cubed. Okay, and again, we're going to go ahead and we're going to do this one by integration by parts. Okay, so with integration by parts, we're going to identify u as secant x dx. And we're going to identify dv as secant squared x dx. We make this choice because v will simply be the tangent of x. Du is going to be secant x tangent x dx. Okay, so here is our setup, and that means that we can equate the integral of secant cubed x dx as the integral of secant of x times secant squared x dx. There's the u, there's the dv. We know from integration by parts that it's going to be uv minus integral v du. So uv, secant x tangent x minus the integral tangent x times secant of x tangent of x dx. So we go ahead and have, I'll go ahead and identify this as integral number 1. And we're going to go ahead and say that we have secant of x tangent squared x dx. Replace the tangent squared with secant squared of x minus 1, Pythagorean identity. Distribute. Secant cubed dx minus the integral secant of x dx. And this guy is what we were trying to integrate to begin with. Okay. So what we have, and I'll put it up here in red, is we have the integral of secant cubed of x dx is equal to our product, secant of x, tangent of x, minus this result here, integral secant cubed x dx minus the integral secant of x dx. So we have secant cubed of x on both sides now. Okay, so what we're going to do is we'll go ahead and distribute this negative. Okay, that's going to change the signs on both of these, and that way we can get rid of these brackets. And we're going to come, this is now going to be a plus. And then I'm going to move this guy over to add to this guy. So now we have 2 integral secant cubed x dx is equal to secant of x, tangent of x, plus integral secant of x. Now the integral of secant, if you remember, becomes that natural log. So we have secant of x times tangent of x plus the natural log, absolute value, secant of x plus tangent of x plus a constant. Now I can divide everything by 2. To get my result. 1/2, and I'll just leave it out here due to space restrictions. Secant of x, tangent of x, plus the natural log, absolute value, secant of x plus tangent of x, close absolute value, close the 1/2, plus the arbitrary constant. And this will be your result. And this example demonstrates that sometimes during the process of integration, you might end up with your integral that you're trying to evaluate on both sides of the equal mark, which means you can go ahead and combine them. So this is a technique or a condition that comes up pretty often. So I wanted to go ahead and demonstrate this technique for you. So this concludes this brief demonstration on how to do powers for tangents and secants. And again, for cosecants and cotangents, it's going to be similar. Remember, you want to try to use those Pythagorean identities to split up the tangent squareds into secant squared minus 1, or you can split up secant squared into 1 plus tangent squared. To simplify those integrands down. Again, use substitutions and integration by parts are also used quite often. So don't forget those techniques either. So thank you for your time and attention.